Hello everyone, welcome back to our channel. Let's discuss the next name reaction, that is Darzens condensation. So this reaction is also an example of condensation reaction. Let's see the statement. Base catalyzed condensation of alpha halo esters with carbonyl compounds to form alpha beta epoxy esters. So these are commonly called as glycidic esters. Here the reactants are alpha halo esters with carbonyl compounds. They are going to treated in presence of a base to produce alpha beta epoxy compound. See the equation. See this is ester group or not? With respective to C double bond O, this is alpha portion. Alpha portion is having Cl, chloro. So this is alpha chloroester. The carboxylic carbonyl compound, general representation is RC double bond OR, is going to treated in presence of strong base. It can produce as epoxy. With respective to C double bond O, this is alpha carbon, this is beta carbon. That's why we are saying the final compounds are alpha beta epoxy compounds. Okay, if you see the mechanism, so initially what happens, the base is going to abstract the acidic proton from the alpha chloroester. See this, this is the carbon where we have hydrogen. This is acidic in nature. Why? Because this carbon is connected to electron withdrawing group. Ester is electron withdrawing group or not? That's why here this one is acidic in nature. So easily the base removes proton from this alpha chloroester. Then it produces carbene ion. The carbene ion involving in the resonance to form the corresponding enolate ion. That enolate ion is treated with carbonyl group. In case of carbonyl group, what happens? The carbon is electropositive or not? That's why it needs electron density or not. See what happened. The oxygen is forming the pi bond, thereby these pi bonding electrons moving towards this carbon. So we will create minus charge here. This minus charge will attack at this carbon, thereby we will get minus. CO minus Cl, and so here what happens, the O minus approaching from the back side, thereby Cl is going to remove in the form of Cl minus. This is called as intramolecular SN2 reaction, nucleophilic substitution. Second order mechanism takes place here, thereby we are coming up with alpha beta epoxy ester. Very simple reaction or not? So simply what we have observed, whatever the C double bond O is there, that is converted into a 3-membered ring. Okay, simply see. This is C double bond O. Carbonyl group is there. That is treated with alpha halo ester. Simply what we need to do, we will convert this one into a 3-membered ring. 3-membered ring. Okay. So here the alpha halo ester may be a alpha halo ketone also. The reaction will work. See this. With respective to C double bond O, this is alpha carbon. So this one is alpha bromo ketone treated with carbonyl group to produce the corresponding one. In place of the ester, we have taken ketone, or we may take the corresponding amide also. So similar kind of product is there. So here what we are observing, in this case ester is there, in this case ketone is there, in this case amide is there. So substituent is changing, right? Now saponification followed by decarboxylation of the produced alpha beta epoxy ester produces the corresponding substituted carbonyl compound. Extended carbonyl compound we are getting. Why? Because the formed alpha beta epoxy esters are not that much of stable. Whenever these compounds are exposed to either base or acid, what happens? They need to be subjected to the decomposition. Okay. So saponification means hydrolysis in presence of base. Already we know that esters will be saponified, then produces the corresponding acids or not. So here initially what happened, in presence of NaOH and HCl, the ester group is converted into the corresponding acid group. Now from the HCl, oxygen taken one H plus, thereby we have created O plus. Okay. In order to satisfy the valency of oxygen, what is happening? These single bonding electron forming the double bond, thereby CO2 is removed here. These electrons are forming a pi bond and these electrons moving towards oxygen. Positive is there, we are giving the negative charge, positive and negative, thereby what happens? Neutralization phenomena takes place. So this carbon is coming with OH group or not? The OH group and double bond. This is in enolic form. Now it is converted into the keto form. So if you observe here, RC double bond, we have taken one carbonyl compound. After decomposition, RCH C double bond OCH3. Extended carbonyl compound we have observed or not? Right? So this is simple Darzens condensation. Okay. Thank you very much.